Small packages traveling on the conveyor belt fall off into a 1 meter long loading car. If the conveyor is running at a constant speed of Vc equals 2 meters per second, determine smallest and largest distance r at which the end A of the car may be placed from the conveyor, so that the packages enter the car. Okay, we know V naught x, which is 2 cosine 30, but we need the time it takes to fall into the loading car, so we can find the horizontal distance r. So, if you look at the first two equations, we can use the second one because the height is known. Taking the positive up from the loading car, the initial height is 3. The final height is 0, and V naught y is minus 2 sine 30. Why minus? Because the y component of V is pointing down, and our positive is assumed up. Solving this quadratic equation and taking the positive solution, the time is found to be 0.69 seconds. And now we can use the horizontal equation to find this value of r. But what is the smallest and largest distance r, at which the end A of the car may be placed from the conveyor so that the packages enter the car? Well, the solution we just found assumes that the total horizontal distance covered is r plus 1. And this means the package will enter at this end of the loading car. Therefore, if we reduce this value of r, which is 0.189 meters, the package will fall outside the car, and it's considered as our minimum r. And if we push the car 1 meter to the right, the package will fall and enter the car from its left end. And the maximum distance now from the conveyor is r plus 1, or 1.189 meters. Note that you cannot increase this distance further because the package will fall outside the car, and that's why it is the maximum.